Welcome to this special last masterclass of the year of the University of Sydney Informatics Hub Masterclass series, also done as part of CSIRO's National AI Month. We're going to wait a little while to get started fully to make sure people have time to come on in, but thank you all for showing up for this special talk on generative AI, and in particular in research. So we'll wait around just a little while longer for people to come in, and then we get started. So just as a note, this is being recorded. Yeah, just to let you all know.
Cool. All right, maybe we can get started and see where we get to, and hope that everyone who isn't here will catch up. All right, so cool. So I'm Gordon McDonald.
And I'm Henry Lydecker.
And we're from the Sydney Informatics Hub, which of course is a core research facility at the University of Sydney. So what we do is we do research and research support, specifically in data science, statistics, bioinformatics, high performance computing, and software engineering. And we're doing this masterclass in just at the end of November as part of the National AI Month, which has been put on by CSIRO. So I'd just like to begin with an acknowledgement of country. We'd just like to recognize and pay respect to the elders of communities, past, present, and emerging on the lands that the University of Sydney's campuses stand on. We're coming to you today from the lands of the Gadigal people from the Eora Nation. For thousands of years, they've shared and exchanged knowledges across innumerable generations for the benefit of all. So we pay our respects to elders past, present, and emerging. The Sydney Informatics Hub, which is where we work at the University of Sydney, is a core research facility at the University of Sydney. So we help people out, researchers in particular, in what they can do with their data science, their bioinformatics, their research computing, their statistics, and software engineering. And we aim to push the boundaries of where research excellence is at. So just to give a quick outline of our talk for today, we're going to start with a little bit of a perspective, a context about what's going on in the world today with AI, and how that's going to impact research. We're going to move on to a little bit of the what, the why, and the how to with regards to generative AI. And then we're going to look at the vision of what we want it to look like in the future. What do we want the future of research? If you're a scientist, if you're a linguist, if you're a law researcher, if you're looking into business studies, what does an ideal future look like? Then we're going to get down into the nitty-gritty with 3 practical tricks that will get you started using Gen AI in your research, and then cover off some more advanced uses at the end, expanding the boundaries of what AI can do.
And so throughout all of this, it's going to be kind of bouncing back and forth between myself and Gordon, but this first bit is going to be mostly Gordon.
All right, so why would you want to use generative AI? So let's start with some broad, general, across all industries kind of stats. So in April, McKinsey did a survey of a whole bunch of industries, a whole bunch of workers. Apparently 40% of workers were regularly using generative AI and 80% had tried it. By the time we get to July this year, roughly 70% are regularly using generative AI amongst working adults. And across the population in general, it looks more like 50% uptake, heavily weighted towards those younger. Some estimates of how much Gen AI will impact global GDP. Goldman Sachs expects it to be roughly a 7% increase by 2030, at the same time as exposing 300 million equivalent full-time jobs to automation. What are the benefits of using AI assistance? Well, quite consistently amongst the research on the benefits of using things like ChatGPT, weaker performers improve a whole lot more. So it's an equalizer. So the top performers in any given area will improve a little bit, but the weaker performers will improve much, much, much more and basically equal out the performance of the two of them. So here's some data from a study that Boston Consulting Group published in September, showing in people that had below average performance on an initial task, they had a 43% gain by using GPT-4, whereas people in the top half, above average, they had a 17% gain. So quite a catch-up. On a really positive note, workers seem to feel that their job satisfaction increases 12% and their feelings of self-efficacy increase 5%. And that was in a paper published in Science in July 2023, which is a bit of a positive note to say that it's not all bad news. And actually, we're looking towards a bright future as long as we do this right. For the bean counters, speed and quality increase as well. 14% more inquiries resolved in customer service call centers. Professional writing is 40% quicker and 20% better. Software developers on small coding tasks can be 50 to 100% faster. And if we look at that along with some other tasks on a bit of a graph here, that's roughly ordered from slightly, maybe somewhat less complex tasks, or at least less demanding in terms of the stringent, accurate guidelines of whether or not the answer is correct, up to increasingly complex tasks that may be both ill-defined and less well and more stringent on how the outcome has to be in order to be correct. We can see that speed and quality both increase up until a certain point. And then beyond that point, according to these studies, they decrease. However, we have a conjecture that we'll hopefully convince you of by the end of the talk, that these ones that get slightly more complicated towards the end, they can also be boosted in speed and quality, but you just have to use a slightly more complicated architecture, a higher level structure in order to get that benefit there. So basically the vision is 100 years ago, very few people needed to know how to type. There were professional typists, which of course still exists, but in a much less, much lower numbers today. But nowadays, can you imagine somebody getting a professional job without being able to use a keyboard? Not really, right? And of course, this is just a historical photo from 100 years ago in the German government's National Archives. So, given that AI is gonna turn into one of these regular everyday tools that we use, like a calculator or a word processor or a spell checker, let's understand a little bit more about it. What is it? So here we've got the black box sitting in the middle. What does it do? You put in an input and you get an output. In this particular example's case, you put in a prompt, which is text, and the output you get is an image that it's created from your text. It's generated that image, which is why it's called generative AI. It can not only create images, but also video, audio, all sorts of other things. Here's another example. This is Henry putting in a little chat into ChatGPT, asking it what's the best way to peel a mandarin, and you get a text output, which explains what the best way is to peel a mandarin with a process that we've cut off. Other generative AI algorithms can take in audio. So if I say hello, and then it will take in that audio, process it through the neural network and come out with ni hao on the other side, translating from audio to audio. those are just the base cases of what we can do. Of course, the most broadly applicable ones, but there's specific use cases that will have a huge impact, even though only a niche audience will actually use the generative AI itself, such as protein folding, DNA, RNA, genetic material, drug discovery, and so on. And one important point that I want you to bear in mind for later on in this talk is that in all of these cases, between the input and the output, somewhere in the middle, there's an internal representation of the meaning or the content that's either been in the text or the image or the audio or the structure. And that internal representation is called an embedding, and it just looks like a string of numbers. But importantly, it's quite a small string of numbers. And the whole challenge in training a generative AI model is to give it enough spread and diversity of data such that those numbers are the important ones, so that it really has a chance to extract the meaning that it needs out of that. Here's just a nice example of an image generator. So this is Midjourney, and we've put in a 3D digital art photo of the University of Sydney quadrangle with some smoke, an artistic style, jacaranda, and sandstone theme. And so we get this amusing image, which looks sort of like it's real life, although of course it doesn't actually exist anywhere in the University of Sydney exactly like that. What are large language models? Large language models, in the simplest explanation, they pick the most likely next word. So in this example sentence, Heathrow Airport is located in the city of, and then it needs to pick the next word. So here we've got a graph on the right of the likely next words and the probabilities that it's associated with them. So it's got London, Birmingham, Manchester, Liverpool, Bristol, Glasgow with some small probability, and the highest one is London. So if we tell it not to be creative, it'll pick London. If we tell it to be a little bit more creative and sometimes by random chance pick one of these lower percentage outcomes, it might produce some more creative output, which may not be correct, but may be creative. This is on quite a simple model related to ChatGPT, but many years previous to it, which has some drawbacks in that it might think that Heathrow is in Manchester, but it also has some benefits in that we can plot the guts of it. So what the colors are telling us here is that the most important word in the sentence so far, before it picks London, is Heathrow. So it's telling us that the model is paying the most attention to the most informative clue, which is the word Heathrow. Cool. Sorry, there was a
noise.
No question? Okay. All right. So some people say a large language model is just a text completion engine. It's just a statistical model. It's just predicting the next word. What does that mean? It doesn't actually understand anything. But think about this. Imagine the power of correctly predicting the next word in these cases. We're in an Agatha Christie novel. We've got Poirot, who is busy trying to solve who killed the chef. And he's saying, the crime is murder. The murderer it is you, monsieur. And then he says the name of the killer. If the LLM can predict the name of the killer, then it's understood the plot so far. A new example. From the symptoms you've described to me, the most likely diagnosis is, and then it fills in the blank. If it's able to do that correctly, it's understood a whole lot about medicine and a whole lot about the patient in front of it. And just a little bit of a facetious example, imagining it could predict the next numbers after the lottery numbers for next week are. That would be quite a powerful ability. All right, how to use language models like ChatGPT well. So first of all, you kind of want to treat it like a smart person who doesn't know a lot about your particular area, but is pretty good at general knowledge and trivia and probably trivial pursuits. So how you do that, you start by assigning it a persona. You instruct it to simulate a specific type of personality or character or constrain its actions. So you might be saying, act like a act like a professor of statistics with 20 years experience. Importantly, that has to be a believable persona. So don't tell it to be a professor of statistics with 20 years of experience, an astronaut that's been on the moon for 40 years and whatnot, because that won't relate to anything in its data set. So it won't be able to do that accurately. Ask for edits to AI outputs. So if you ask it for something and it gives you something that wasn't quite what you wanted in return, tell it to change it. Use the fact that it's a conversation to modify and get towards what you actually wanted by the time you get to the end, much like you would, for example, a smart intern. Teach by example. So give a few examples of a correct answer to a similar question before asking it the real question that you want it to answer. If you modularize the tasks and you break it down into small units for the AI to execute, it's much better at doing it. However, it doesn't have to be you that breaks down these tasks, as we'll show you later on. It can break it down for itself. And then ask for explanation, challenge it on things that it might have spewed out false information on, and ask it to explain its logic in how it got there. Some important considerations. A lot of these technologies are sitting in the cloud. For example, ChatGPT, your data is currently being sent to the US, which means that it's not appropriate in research for private medical data, personally identifiable information such as people's names, addresses, credit card information. You would not want to send things that you want to protect the IP of, for example, military, biomedical, space technology that you want to commercialize and be able to protect that IP. You would not want to send that overseas. So then you would want to make sure that whatever generative AI solution you're using, you control where that information goes. So that could be a local model that's running on your laptop. That could be a model running on cloud that you control. That could be a model that's running on cloud that satisfies all of your data security, privacy, governance, and sovereignty requirements, if that's medical data, for example. There's a whole bunch of ethical considerations involved. For example, fairness and bias in the outputs of the model, what the source of the data is the source data that it was trained upon biased towards one particular avenue or another? What is the impact of the model that you're developing and how it will be used? What is the impact of that? If we're replacing people making decisions with AI making decisions, who will be most impacted and how will they be impacted badly? It's important to consider those things. In terms of academic integrity, specifically in research, you want to make sure that, first of all, your model is accurate, that you're speaking the truth. If you're using it to help you write, for example, you want to make sure that you've correctly attributed it according to the policies of whatever journal or place that you're publishing is, and that, importantly, that you are accountable for the output. If you are submitting it, even if the generative AI created it, you need to be the one that checks it and makes sure that it's true. And lastly, reproducible. For example, in the case of code, we want it to be producing the same code output. We want the research to be reproducible, which means that if we've generated some code, we want to save that code somewhere so that somebody can rerun it. We don't always want it to be reproducible and accurate. Sometimes we might want creative writing, which is sometimes a part of research, but it's not the majority of it. Lastly, cost and practicality. Make sure that if you're running a model over 10,000 data points, that it costs you $10 for each data point, then that's going to cost you $100,000 and you might not have $100,000. So just make sure that it's going to be financially feasible, scalable, and reliable. And lastly, reputational risks, things that you might have to sometimes worry about. For example, if you put out your model, which diagnoses someone or other, let's imagine you've got that through the TGA somehow, and then it creates some fabricated reality in its head and outputs something that is bad for someone in a health context. There's probably publicity and liability from inaccurate and inappropriate responses of that AI that you might have to face up to. So it's important to consider those as well. Yeah, so be aware of the policy of your institution around that private data. One of the potential solutions is local models. This slide is from a while ago, but you can see that there are openly accessible models that you can run on your laptop that are quite close to the accuracy of the state of the art, and they're rapidly catching up. Of course, there's ethical issues to worry about as well. For example, when developing ChatGPT, in one of the training steps, they got people to look at a whole bunch of not safe for work content in Kenya. They were all paid below US minimum wage, but actually far below Kenyan average wage as well, to read about content including murder, sexual abuse, suicide, and incest. And they had a terrible time. And in the end, the company that they were subcontracted to by OpenAI didn't even get paid, and they cancelled the contract. So, that probably falls under the modern slavery policy for the University of Sydney, and whatever policy is equivalent for your institution as well. So something else to think about. Make sure that when you use it according to the policies of your institution, your funding bodies, and your publishers. For example, the journal Nature says that you are perfectly allowed to use AI-generated text as long as you are taking responsibility for the content. But you're not allowed to use AI-generated images, with the point being that they don't want fake microscope images or fake scientific diagrams, fake scientific images of data that never existed. So
the figure can't be fake, but you can use an LLM to write the text to describe the real figure.
And to help you write the code, to analyze it, as long as you are taking responsibility that it's doing the right thing. A little bit to the side of research itself is how you get the money for research. So this is a thing that happened back in June and July, where a whole bunch of reviewers for the Discovery Project grant funding, when the ARC was doing that last round, used ChatGPT. And so when they copy pasted ChatGPT's actual response about this grant proposal back into the ARC's portal, they left in a little bit at the end. You know how there used to be a button that said regenerate response? So they copy pasted and included regenerate response at the end of the grant proposal, which I think is pretty funny that they couldn't even be bothered to check their copy paste. So that prompted a bit of a scandal, and the ARC has released a statement saying that if you use it in assessing other people's grants, then you may be breaching their research integrity policy, because you're breaching the confidentiality of the person who wrote the grant application. For a fun side note, if you go on LinkedIn and you do a search for regenerate response, you find a lot of people that did the same mistake, although that button is no longer there in the current version of ChatGPT. All right, so I'll hand over to Henry to elucidate our vision.
So we've just spent a little bit of time going over a lot of the basics about generative AI, and then also talking about some of the things that we need to be aware of. And now it's time to think a little bit more about like where we want to be and how this can kind of guide us towards a really good future. So we have these like sort of three categories here. So you have the three positive aspects of how AI can make research better. It can improve efficiency and productivity in almost every single aspect of the research lifecycle. It can reduce friction and interruptions from work, from having to spend time doing some grunt task or busy work that interrupts you in the middle of something that you really actually want to be focusing on. And it can democratize access by making it so that all of us can use whatever language is most comfortable to us, including our own language, to drive complex tools and analyses. And so what this could look like in practice is, imagine you have a researcher who's trying to do a literature review to inform their next phase of their project, or maybe a grant application. They can more effectively interact with different documents using large language models. Or what about a researcher who's sitting there looking at microscopy samples? It takes forever to go through there and label every single cell. Instead, they can use a multimodal assisted annotation platform to go and find cells for them. And we'll talk a little bit more about that later. Or you have a researcher who's like, oh, I really don't want to learn how to program, but there's this bit of analysis I need to do. Suddenly, it's easier than ever for them to get access to cutting edge analysis techniques in programming languages like R or Python to enable them to more easily transform their research into actual results ready for publication and create interesting, engaging figures, even though I personally don't think heat maps like this are that useful. Apparently they are, and people love to publish them. So that is something that actually does help get bioinformatics papers through to publication. It can also help you with grant writing. I know grant writing is a huge thing that many people complain about. It's hard to figure out what's the best grant for you, what are the best funding opportunities, and how to best to apply for these, and LLMs and LLM-based tools can help this. Finally, communicating science is one of the biggest obstacles for a lot of people, whether it's getting into really high impact publications like Nature or communicating the results of our research to the general public. And this is something where LLMs can help us a lot. Something I like doing with it is like asking it, can you explain this like to a 5-year-old? And it's actually pretty good at doing that. It does a pretty reasonable job. So next, we've got this kind of clickbait-like title of 3 generative AI tips for research. And I'm going to start off with the first one, which is about applying knowledge to make our generative AI tools better. And specifically referring to a technique that's is probably, the name will probably change over time, but currently it's known often as retrieval augmented generation. We left that in. So, okay. So by default, many of you will have seen this. If you interact with something like ChatGPT, just in its base implementation, you ask a question and it's going to give you a response. It's going to try to give you the most likely, most realistic response. In this case, I asked it, can I connect my personal device to the university's network? Now, this does not know what university I'm in, does not know where I am, but it gives me a response. It says, certainly, I can do this. And it gives me an answer which is kind of vague and it doesn't actually apply to anything that's actually relevant. But it looks kind of right because this LLM was given a system prompt to be a helpful AI assistant. So it will try to provide you an answer that looks right, that feels right to it, that might look right to us, but it's not using information. It's not going and Google searching and finding out what university I'm at. It doesn't even ask me that. It just gives me this response. So the thing here, yeah, is that these bots don't think to themselves, they don't think, they don't go and they don't look for information. Instead, they just provide something that's plausible. So say if you ask, hey, who came up with this bit of research? It can just come up with just a made up paper. And this has actually been found out by many people is that they've attempted to use LLMs to either write legal briefs, and then it's just generated completely fake things here, and that's obviously not good, particularly in law. And also, researchers have used it as well with accidentally using fake reports coming from Bard, but that's their fault for using Bard. No offense, Google. So the solution to this is this technique called retrieval augmented generation. And so the basic idea is that you provide knowledge to these LLMs, provide them a way to interact with a set of knowledge and to look through it and to try to find bits of information that are relevant to answering your question. And so one of the ways that we implemented this actually was this sort of architecture here, where we use one LLM to interact with a user's question, receive that question, and then go look at a set of documents that have been processed using another LLM into this sort of bank of knowledge. And then what happens is when a user asks a question, then the LLM goes and looks in there amongst that knowledge and tries to think, is any of this relevant to answer the user's question? And then if it finds something that's relevant, it will then provide that back to the user with a little citation and say, hey, this is my answer. This is what I think you got. And what that looks like in practice is something kind of like this. So say asking, a question, can I take my IP with me and use it for whatever I want? And this generative AI tool here has access to all of the University of Sydney's policy documents. And in this case, it searches over there and tries to find the most appropriate policy documents, and it gives you an answer with citations referring back to the original documents. In this way, our LLM is grounded in, or is given the tools and the knowledge to be able to answer someone's question. And this prevents it from hallucinating. So some of the ways that this could help empower research. Imagine you're doing a lit review, right? Or you're doing a meta-analysis of something, and you want to interact with your whole set of documents that you have there on your computer. Well, now you can ask questions using natural language, using retrieval augmented generation to go refer back to those source documents and find the appropriate responses for you. This is really useful. Imagine all those times when there's like miscitations. Instead, this hopefully could reduce things like that and free up time for people to write hypotheses or come up with ideas based upon the information stored in all of those papers. Could help you with finding the right grant opportunities for you. It can be really opaque to figure out what's the best funding option, what you're actually eligible for, what are all the considerations involved. Instead, you could have a tool using retrieval augmented generation to look over all that stuff and help you write grants. Finally, something like that policy navigator that showed off in the last slide. Policy documents are really hard to understand. They can be spread out across many different sources and organizations, and there can be a lot of conflicting different things to look over. And a tool like that can help, reduce liability and just, streamline the whole process of understanding how organizations work. So overall, retrieval augmented generation is a really cool technique, and it's a huge way in which AI will make all of our lives a lot easier. And there's many different ways we can work with this. So all of the big cloud providers are implementing retrieval augmented generation and all their toolkits they provide. This is a little bit more developer focused, but there are many different offerings that provide this service. It's integrated into different tools like Jupyter AI, ChatGPT Pro includes it in there, of course, for a cost. But then there's also standalone tools that will now allow you to create this, whether through actual programming using something like LangChain or through more visual programming with tools like FlowEyes or even one of the University of Sydney's kind of related tools of Cognitive. And for the next set bit, then I'll hand over back to Gordon to talk about some of the ways that AI can make data analysis a lot easier.
Cool. So conversational data analysis. Wouldn't you love to put in your CSV and then just chat with your computer to get to the answer? Yeah, so real world data is messy. A data scientist might spend 80% of the time cleaning it before they actually get to the modeling part, which is what happens before you get to understanding what's going on in the system, which is the useful outcome for research anyway. So there's a lot of time involved in the plumbing. Programming languages like Python and R, they provide very powerful and efficient ways to clean and analyze data, but there's a barrier to entry that you need to learn how to code in those languages. And that takes a significant amount of time. And it used to be necessary, but now it's not necessary. So here's how you can do this kind of stuff without learning how to code at all. So what we're doing now is we're interacting with the computer in a language that we understand, in this case, English instead of Python. So what we've got here is we've got an example in ChatGPT's code interpreter. It's called the Advanced Data Analysis plugin now, but now it's just kind of basically in GPT-4 if you pay for the ChatGPT Pro subscription. So what you do is you upload your spreadsheet, you give it a big prompt. So I've told it you're a data scientist, figure out what's in the CSV file, do some exploratory data analysis, summarize, work step by step, and ask some questions of the data, and then ask me if that's what I want. So it loads it, it does some Python code, doesn't even show me the Python code, but then it tells me about what the answer is. And it tells me that in that particular CSV, there's some information about properties, their address, their land zoning, their costs, their what authority they're within, what local government area. Then it does some summaries, gives me the top 5 suburbs with highest average land values, tells me the number of unique districts and suburbs involved in that particular file, which came from the New South Wales Land and Property Register. So yeah, basically you can figure it out, summarize my data without me having to actually put in the prompt anything about what that data was. It figured it out, it summarized it, it did some EDA, not like exactly everything that you might want in EDA, but it's a great start. However, that's a paid subscription with like $20 US a month. Who wants to pay that? Let's not. Here's another tool. This is Open Interpreter, although it's quite similar to Jupyter AI, and I think Jupyter AI is slightly better. They're both tools that run in a Jupyter Notebook or Google Colab. So basically what happens is it's exactly the same as before. You can upload your data to wherever your Jupyter Notebook is happening. That could be on Colab or that could be locally if it's a local Jupyter Notebook instance. And then you ask it in English. Do something in code to my data, here's the path of the data, go. And you might give it further specifications according to that list of guidelines we gave you earlier, right? So what it does, it'll make a little plan, it'll write some code, execute the code. If the code doesn't work, it'll find the error and then try at least to figure out how to get past the error and keep going until it gets to the end. Hopefully it gets to the end and then it shows you the result. So in this case, what it's done is it's done some topic modeling on a bunch of restaurant tags from Google Maps. When you look up a restaurant on Google Maps, they'll have a bunch of keywords that might relate to Japanese food, sushi, fresh or something. And then, so what we've done is we've done topic modeling to cluster those into topics across all of the restaurants in a particular scrape of Google Maps. So that was fantastic. Here's another alternative that allows you to do the same thing. So this one is specific to R. Well, it's not actually specific. You can also do Python in here. This is just one of the examples that you can do in it. So you upload your data to this tool called rtutor.ai, which is running in an R-Shiny app. It then sends off its prompt to ChatGPT along with your query and comes back with some R code, which it then evaluates to give you your plots, your analysis, and then you can keep going. Same as before. So multiple ways to do this. Which one will win out in the end? Don't know, but they're all looking promising. Back to the plumbing at the beginning. 80% of a data scientist or statistician's time is spent cleaning the data before you get it to the point at which you can do the interesting analysis or plots or modeling. Here's a tool that will help you to do that in lightning fast speed. So GPT for Work is a tool that you've got to pay for in Excel, but in Google Sheets at the moment, you can use it for free. You've got to have an API key. All of these, you need an API key from ChatGPT. But what you can do is, say you've got your unclean data on the left column in column A there, which has got an address and an email and a phone number all kind of mixed into one. And sometimes the order's a bit mucked up and sometimes there's like spelling errors and who knows what. You just want the email, right? So what you can do is you can use one of these pre-made functions, or you can just put in a straight ChatGPT prompt and then put in the contents of the cell in column A, and then it will send that off to ChatGPT, get you the answer, and put it in column B. So if you set it up to extract the email address, it'll just do that. And this way, you didn't have to figure out how to do regular expressions, how to do whatever else. But not only that, you can do things that are more complicated that you would not necessarily be able to represent in regular expressions. Concepts that might be vague, that might be ill-specified. For example, you might say, here's a list of all of the research projects that I've been working on recently. Classify for each one whether or not it has anything to do with cancer.
And so things like this could empower almost anybody, because every single one of us, I'm pretty sure, has had some Excel spreadsheet we've had to work with, and then somewhere along the line we've entered something in misguidedly. This makes our lives easier.
Yeah, this makes our lives so much easier. As mentioned previously, you don't want to put private data in here. Don't put secret stuff that you don't want to share as open source forevermore, because you don't know where it's going if you're sending it off to a cloud service. However, if you set up something like this locally, then you don't have to worry about that anymore. It's staying on your computer. Tip number 3, maps of meaning. So back when I explained how a generative AI tool works, and we have that black box in the middle in between the input and the output, and inside the black box, the input gets reduced to a string of numbers that represent the meaning in whatever that means for that particular use case, which could be what are the topics being discussed in a piece of text? It could be what objects appear in an image. It could be what the sound of someone's voice is like in an audio file. Okay, so that's been reduced to a string of numbers. If you reduce a large corpus of such data to those numbers, we can do something really cool with them already. So for example, let's pick a corpus. So this corpus is 4 subreddits on the social media website Reddit, and we've taken each post, of which there's been a few thousand, one from the subreddit language technology, one from the subreddit Python, one from investing, and some from PyTorch, right? So we've got a couple of thousand articles, posts from each of these. And all the model sees is the model sees a big string of text. And what we're doing is we're extracting that semantic embedding of meaning from each of those posts. And then what we do is we plot them on a map. So there's a bunch of techniques involved there beyond the embedding itself. We're using UMap in this particular case to do the dimensionality reduction. But anyway, the important point is that each one of those dots represents one of these posts, like those 4 examples around the outside. And it's put them on that map in such a way that things that are nearest to each other are going to be the most similar in terms of meaning, and things that are further away from each other are going to be less similar in terms of meaning. And you can see that that's come about because you can see that each subreddit is relatively closely correlated with itself. It's in a cluster. These 3 are not all that different from each other, but they're different enough to separate, because you can see that all 3 of these ones involve something to do with Python coding at some level. PyTorch is a particular library used in Python coding. R Python is just everything Python, and language technology happens to have a lot of, here's how I did something with an LLM in Python. So they have a lot of overlap, which is why they're all next to each other, but all 3 of them are quite different from investing subreddit, which is all about financial collapse, what should I do with my own finances, these kinds of things, right? So that's quite a different subject matter material. And of course, there's some overlap. Perhaps some people are doing some Python coding around investing. But imagine you have a different text corpus. It could be the completed works of Shakespeare. It could be a bunch of interviews that you've done. It could be a whole corpus of historical text that you've collected with 9,000 different opinion pieces in the newspaper over X years or whatever. How powerful is it to be able to draw a map of the entire thing in one view, and then to drill down into each little dot to see what that article was and what it's next to and why, to try and formulate your hypothesis on what's going on here. So this is when you get a text input to a semantic embedding. Oh, sorry, one last step. Once you've grouped them together into topics, you can also pull out, the most common terms in each of those topics. So these are the most common terms in each of those topics that are kind of illustrating for you what's going on there. You don't always have to use text. You can do it with images. So you can say, for example, what we've got here is the MNIST handwritten digits data set, which is a classic machine learning data set. It's got some quite small pictures of handwritten digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, written by a bunch of people, a whole bunch of times, thousands and thousands of them, just a whole bunch of images. So what you can do is you can do that same semantic embedding with a different generative AI tool. And then you can plot that on a map instead, and you can see that quite naturally we've got clusters of the different digits in different places from that semantic embedding. So we can see that 3 is all the way over here, 2 is on the right, 4 is up the top, 0 is on the left, and the different zeros can go from skinny to fat to elongated to missing a little bit as you go further up to the top, and it gets a bit confused as to whether it's a 4 or a 0, because if you look at that particular example, it's a bit hard to tell. So you can do this for text, you can do this for images, you can do this for anything. You can chuck into or out of a generative AI model. So it's a very powerful technique to map your whole data set in one place and see what the commonalities and differences are. And now I'll hand back to Henry for some advanced uses.
So all of those different approaches we've gone over have pretty much involved, using either basically one model, or one model maybe multiple times. Things start to become a little bit more complicated, though, when we think about things that are called multimodal models. So when we're talking about modes here, it's kind of referring to a domain they work in. So a lot of those previous ones are language models, so they work with language. But what if you're able to combine language models and visual models together and work across multiple different domains? This is where you have embeddings that you work across those multiple areas. So one area is with image understanding. You could ask what's in the contents of an image. In this case, feed in an image and ask what animal is in here. It says there's a koala. Another possible application could be medical imaging, asking like, well, what is this? And trying to understand things about the imagery. In this case, it's gotten some pretty good explanations, but then again, I'm not a radiologist about this X-ray here. And finally, you could do things like, say in this example is work with geospatial imagery. You could provide a text prompt and say, find me all the trees in this picture. And the model does a pretty good job of finding all of the trees. And this is actually a real example. Those other two examples are kind of just from playgrounds. This trees one is from an actual bit of software that we're working on developing. The other way to really expand upon LLMs, besides just providing them, with other modes to work in, is to work with what's called agents. There's many different implementations of this, but basically the idea is to start stringing together several different LLMs with maybe different system prompts, different bits of behavior, and giving them different tasks, and then have them all work together to accomplish a lot more complicated tasks. So in this case, imagine you could have a team of agents working together, each of them given a different a different task, work together to build a Python application. You could have some of them that might be like the CEO, that you come up with the general idea, lead the whole team of agents. You could have another one that's like, I don't know, a junior developer that's working on an individual feature. You could have a senior developer reviewing the features developed by them. You could have a product manager orchestrating the teams, making sure that it fits user needs. And all of these agents can work together to accomplish really very complicated tasks. One of the really widely known applications of this is something called MetaGPT. There's also Agent GPT, which is very similar. And this can be used for all sorts of different applications. You could, imagine you could make a whole research team. You could make a whole travel agent squad to plan out the best possible trip for you. You can give them many different tools to work with, different prompts to engage with. And the idea here is that you can if you can break apart these complex tasks into more constrained tasks, you can get these agents to work on those individual little components and together do a lot more complicated things than just one LLM working by itself could ever possibly accomplish. And I guess this is, one of the caveats here with using any tool like this is it really does depend on your understanding of the thing that you want to accomplish. If you want to do something, you need to make sure that you're providing whatever LLM here. Even if you're using agents, you're providing it with a description of the task that fits and actually will allow the agent-based model to act and create the thing that you really need. Because if garbage is thrown in, you'll get garbage out. There's many other different applications of it. One of the big ones is with audio transcription and translation. This is really powerful. You can have really like live audio for translation from one language to another, from text to another. You can translate languages really easily. You can go from spoken to written. You can go from one spoken to another spoken. You can go from written to spoken. That last one that's linked there, 11 Labs, is a really good commercial product. It works best with people's voices who sound like standard North American English accents. It works less good with other voices, but they're working on getting better. So yeah, there's many different applications for this. One of the really exciting things here is it kind of like democratizes and opens up access to different areas because we can more efficiently and effectively translate languages, because LLMs and tools built upon them do actually a really fantastic job at working with translating between languages, which makes sense seeing as they're language models. Finally, there's really these are a little bit more of niche models, but they're going to be impacting our world in many different ways all around us. So these are sort of generative techniques for generating things besides just language. So this is things involved in like drug discovery, in a lot of biology and materials research. So interestingly enough, when we were preparing this slide deck, at first we were just talking about generative biology, that's where we have these models that can then run and kind of come up with new ways to fold and develop proteins that can then guide drug discovery. But right while that was happening, actually literally yesterday, the same group that put out AlphaFold put out this massive new model for doing materials discovery. And the idea here is that this can help us come up with all sorts of different crystal structures that can be then used to guide development of new materials that can be used for more environmentally friendly engineering, developing better, more efficient energy storage and semiconductors, that kind of stuff. And even AI manufacturing and synthesis of all of these new AI-generated proteins or minerals. There's also AI fabrication that's being developed and researched. So this is quite exciting. I admit I don't know as much about it since I have background in ecology and I'm a data scientist, but it's really fascinating to see how these things are actually going to be changing a lot of different disciplines. This is an area where these techniques are freeing up efforts that might be used, coming up with different ways to fold proteins and develop materials, instead thinking about, well, how can we take the properties of these things that our AIs have developed and apply them to solve real world problems. So it's one potential area where AI could be really speeding up the time to translate raw information into actual research impact, both in publications and in actual real world uses. And so I guess we're kind of going to wrap up here then. So we have this kind of inspirational bit of, so what will you build? So there's many different opportunities that are available here. Whether than it's just, it could be just working with using a chatbot more effectively, or it could be developing some sort of complex agent-based workflow to engage with multiple different inputs to solve some crazy cool problem. There's many different ways that we can use generative AI to empower and drive a kind of a better, more democratic and efficient research ecosystem going on into the future. And so we had a couple of questions while we were going, but otherwise I think we're happy to open up to questions as they come.
Yeah, so what questions have we got here? What does the competition look like if everyone has access to these AI tools? Well, that's kind of it's a plus and a minus. The minus is there'll be heaps of competition. The plus is everybody can use these tools really easily. So like society as a whole will progress further and faster towards, hopefully, if we shape it right, a better future. Another question is, can you use these translation tools for research if you work in bilingual research project? I think Google Translator is not acceptable. So yes, you can. If your data is private, you'll want to use a local model, but luckily that's actually quite easy to do for that particular task. And sometimes they can be better. Sometimes they can be better than Google Translate when they do that for some use cases.
So one of the things that these LLMs can do better at is, like, sometimes if you ask for a direct translation between languages in Google Translate, it will give you a literal translation, but that might not actually be a real translation because nobody would actually speak like that.
It might not be a translation of the meaning. Like for instance, in Mandarin Chinese, they might say, don't be a light bulb, which translates to that in English. But if you translate the meaning, you're saying don't be a third wheel.
There's all sorts of different weird idioms and phrases that we use in languages, and LLMs can get them.
The large language models do a lot better on those than Google Translate's model does.
It's a question, can we get free access to GPT-4 on campus?
No, sadly, that's not available at the moment. Although what you can do is you can create a chatbot in Cognity.ai, that the tool that we mentioned earlier, which is created by a University of Sydney professor, Danny Liu. And through that, I think you might actually be able to, maybe, at least for now. Do we have any more questions from the audience while we're here? Just to answer the question earlier, the presentation will be made available. We'll send around that and leave the link on the YouTube video as well when we upload the YouTube video.
I have a quick question for you. You've mentioned a lot about the usefulness of utilizing a constraint, which you call a constraint. So my understanding is that it really limits the parameter of for ChatGPT to potentially elaborate the information or even to trim out some irrelevant information in the response. Is it okay for you to elaborate a little bit on that? I don't have a programming background, so I appreciate the kind of the later half of the kind of a more advanced approach to LLM, but just from a broad conceptual perspective, can you just describe that? Well, how can we best apply constraint in the way we interrogate or pose questions on ChatGPT for the purpose of research?
So I think there's two kind of ways to approach that. I don't know if Gordon, you want to elaborate more after me, but so one of them, most of these LLMs have this one parameter of them that's called temperature, and that basically controls how creative the model will be with its output. Now, depending on the actual LLM application, sometimes that will be visible to you, and as a user, you can like adjust that. Other times that needs to be set like through using code. I think some of the code, like the code playgrounds and stuff like that, they'll allow you to set that temperature. The other thing to do is kind of to set a new system prompt and specify specifically what it can do, what it can't do, or even give it like a worked example of like, you are a chatbot that is going to, I don't know, look up, tell me about something, and then you have to give it a specific example and say, do this, only give responses in this way, give your responses, make them short, make them concise, don't include anything else besides something referring to the specific thing. So like there was that example we showed of this policy chatbot. That one was given very specific, several different specific system prompts that really concisely confined what it can do. So that's taking a general model like GPT 3.5 that could write Python code for you. But if you ask that model to write Python code for you, it will refuse because it's been told, don't be creative. This is what you're allowed to do. Don't stray outside your box. So those are some of the ways that we think about it. Now, defining the right system prompt that will get the behavior you want, that can be difficult. And that's like this kind of buzzwordy term of prompt engineering there. And there can be a lot of work to find the prompt that gives you just the right answer that you're looking for.
But just to add to that, instead of thinking of it as this kind of black magic tool that you play around with, and you've got your magic prompt, and then you keep your prompt secret because that's your IP or whatever, I would encourage you to think about it as, if you're from a programming background, Ivy, I would encourage you to think of it as test-driven development. So write your tests first, which means you have questions that you have a known good answer to. So you have an example question and a model answer, and you have a list of those. And every time you change the prompt or change a parameter, you want to ensure that it's still answering well to that list of test questions, where those test questions are now just human questions rather than perhaps programming assertions instead.
Yeah, that's really helpful. Thank you very much. And I think it sounds very much like using both constraint and also having the test question handy means that you're really training. We were training the best as we can to train the ChatGPT within like a confined environment and to get close to what we want. Is that correct?
Yeah, basically.
Okay. Thank you.
Cool. I guess we're almost out of time. I guess Andrew's just said it must be hard keeping up with the speed of technological advance. Yes, it is. It's like an exponential rate of change, which makes it quite difficult to see what's coming around the corner. But you just got to kind of see what comes out every day.
I think what's really fascinating actually about it is that just GPT, like the model, like GPT-3 has been around for quite a long time, like 3 years. But so this model that powers ChatGPT and has driven so much hype, it's only really came about this year that it's just because of the way that they provided to interact with it. So it's quite fascinating that actually one of the key aspects here is not just the raw models, it's also the implementation in a tool that's easily accessible and understandable for users. And so that's a really important aspect of it that's allowed some organizations to be very successful for this tech to explode.
Cool. I think we are basically out of time. Thanks for coming along. I can see a bunch of good questions that have come up just at the end there, and I'll try to get back to you each individually. Thanks for your questions, and thanks for coming along.